So we've been over the basics of how to plot rectangular complex coordinates in a coordinate plane with the real and imaginary axis. And now what I want to do is talk about three ideas. We're going to plot a complex number with its conjugate. We're going to plot a complex number with a scaling of itself, so twice that complex number, and this would go for 3 times or 4 times. And we're going to plot a complex number multiplied by I being the imaginary number. We're going to see what effects these three different things have. Now, if you're interested in one particular one of these questions and not the others, we'll just zip ahead. It's the first part of the video for number 1, second part of the video for number 2, and by the end I'll be doing number 3. So, remember what the complex conjugate is. We should be able to buzz through this kind of quick. -5 plus 3i. Okay, so if I plot the conjugate, it's going to be -5 over this way, -3i down, I get to here. But if I go -5 plus 3i, that takes me up to here. Okay, so there's my points. This one over here being z, this one over here being z conjugate. And now just check out what this wants from you. It says also, while you're at it, why don't you draw a line from the origin to the point z, or z conjugate. Okay, so we've got one of those, and we've got one of these. Now these lines are just for visual purposes. They just kind of help you think about what's going on here. The important part's the dot. So what is going on here? What kind of a transformation is represented by changing this line right here, give me my color here, by changing this one to its conjugate? What is happening in terms of transformations? Well, that looks to me like it is a reflection. See, we have our graph here, and it's getting popped over the y-axis, right? So it's a reflection over the y-axis to the conjugate. Here's another example. Now in this one, we're multiplying the complex number z by 2. So what do we get here? Well, this is just going to be -2 plus 2i. Okay, pretty straightforward. So let's plot the original point. I'm going to use black now for this. -1 and -i. That's just going to be right here. And the scalar version of that is going to be right here. This is it times 2 at -2 plus... I can't do math. Okay, bear with me here. -1 plus I is up here. -2 plus 2i is over here. So if we plot lines for these 2 points, and this might be a little bit tricky because they're on top of each other, but here's what we're getting. There's one, and here's the other one. So you can see what's happening here is this is a scaling by a factor of 2. In other words, it's getting bigger. When you multiply by a real number, all you do is you take that complex image that you have there, that line and the dot, and you simply stretch it out. So we've got a stretch by a factor of 2 in this one. That's what multiplying by real numbers does. Multiplying by complex numbers is rather more interesting. Let's start with, what is this thing even? This is a formula. So what I want you to do is plug in w into this formula, and here's w right here. And then multiply it by I to the nth power, where n is whatever this little itty-bitty index is right there. So as an example, for this first one, z0 equals w, which is 2 minus 5i, times I to the 0th power. Now, I to the 0th power is like anything to the 0th power. It's 1. So this just becomes 2 minus 5i. And I'm going to use different colors here because we have a few things to keep straight. In this next one, this is going to be 2 minus 5i times I. Okay, so what do we get here? Once you rearrange things and simplify, you'll see this is going to be equal to 5 plus 2i. Okay, let's keep going. How about this next one? This is going to be 2 minus 5i. That's the w portion. And then now we're doing I squared, which means times a -1. So this becomes -2 plus 5i. And this very last one, I hope I'm picking colors that show up well. That won't. Let's do orange. This very last one is going to be 2 minus 5i times I cubed. Well, I cubed, if you remember, is negative I. So it's going to be the negative version of z1. This will be negative 5 minus 2i. So now let's plot all these things on the graph and see what we're going to end up with here. The first one, 2 minus 5i, lands me right here. I'm just going to go ahead and draw this line while I'm at it. The second one, or z1, is going to be 5 plus 2i. Okay, so that's going to be over here, like that. And then negative 2 plus 5i is z2. So negative 2 in the real axis plus 5i in the y in the imaginary axis gets me up here. And then last portion, negative 5 minus 2i lands me over here. And there we have it. This is not a coincidental graph. This is quite intentional. Every time we multiply by I, we rotate by 90 degrees. Okay, so these are rotations. That's the kind of transformation that multiplying by an imaginary number gives you. And these two concepts, this of rotations and this previous one of scalings, turn out to be the most important things to remember when you're graphing complex arithmetic.